Hi there, this is Tijs. Now in this video we'll cover the entire content of the DA-100 exam, analyzing data with Microsoft Power BI. This video will cover the entire content following the structure outline as given by Microsoft. My role in my day-to-day work is being a business consultant in a Big Four company based in Belgium. I did the exam because I wanted to become better at data analysis using Microsoft Power BI. I actually did the exam twice because the first time basically I was unprepared. So I want you to avoid making the same mistake I did and just pass on your first try. Although I'm not a technical computer science profile, I don't think this is necessary for people to learn data analysis or even teach it. So without further ado, I wish you best of luck with the course and enjoy learning. Alright, let's get started. So the DA-100 exam. It's a new Power BI certification exam out since July 2020. It replaces the older 70778, Analyzing and Visualizing Data with Microsoft Power BI. The exam is for you if you want to become a data analyst, or you want to leverage the available data within your organization, or maybe you're just getting started with Microsoft Power BI and you want to get a better understanding of the different capabilities. The exam, however, is not for you if you've already used or if you're using Power BI extensively, but you want to get more familiar with DAX and QueryM language. The exam is $165 US. It takes 150 minutes, so 2 hours and a half, and you have to get a passing score of at least 70%. The exam is also only valid for 2 years. It's important to note here that given that I've done the exam myself, I had to sign a non-disclosure agreement which permits me from giving away any hints regarding the exam structure or specific questions. However, it's on the Microsoft certification site, that the exam typically contains around 40 to 60 questions. So how do you study for this exam? Well, this video will cover the majority of the content on the exam, but it won't cover all of it. There is an online learning path provided by Microsoft, which you can follow, but we feel it's a bit elaborate for people who want to get a better understanding and want to have a quick grasp of the functionalities. There are also a number of YouTube channels out there that tackle specific items, such as Guy in a Cube, SQL BI, which is mainly focused on DAX, and also Kerbal. Lastly, it's important to note that the fastest way to learn is to just open Power BI Desktop and try things out yourself. So how long will it take to cover this exam? So I've made a distinction here between experienced, so that would take you around 3 to 7 days to get accustomed with workspace roles and maybe freshen up some things that you're not truly familiar with. For people who are in sales, finance, or IT in their jobs, it would take about 2 to 3 weeks. If you're new to Power BI, it will take around 30 days. Note that this is all 8 hours per day, so it's quite a broad exam and you need to be aware of that. Alright, so what is the content outline? The majority is in the first 3 parts, so prepare the data, model the data, and visualize the data. Model the data. Prepare the data includes get data from different sources, like databases, SharePoint lists, or Excel files, analyzing what the distribution looks like, and see if there are any errors in the data. Modeling the data is truly the design of a data model. We'll also learn how to configure relationships and create measures using DAX. Model the data is the bulk of the content.
almost 1/3 of the exam, so make sure to pay sufficient attention to this section. Visualizing the data is creating reports, creating dashboards, and learn how to add tooltips and bookmarks to enhance your reports. Filters is also an important part of this. Next up is analyze the data. We'll look at how to enhance reports to derive useful insights and how to make your reports interactive. We'll also learn to work with the analytics pane and look at some of the new AI functionalities Microsoft has added to Power BI. Finally, deploy and maintain deliverables. We'll take a deep dive into the Power BI service, covering workspaces, deployment pipelines, and how to set up subscriptions. We'll also take a look at how we can schedule a refresh, or at least set up a scheduled refresh. Important here as well is to always make sure that you have the latest exam outline on the dedicated Microsoft page. You can find the link of the latest outline in the description.
Power BI Desktop is where you load your databases, transform them in Power Query Editor, and create relationships between databases. After loading our data and setting relationships, we create visuals in the report segment. In here, we can create all kinds of visuals to show our data in the best way possible and derive useful insights. After we loaded and transformed our data, we will be able to see all the rows and columns in the data segment. Relationships are shown in the model segment, where we also set our relationship type and storage mode. Power BI Desktop has two models, the report view, which is the default view, and the Power Query Editor view. For those who have experience in loading data in Excel, the editor should be familiar. The Power Query Editor shows up when you load a database and click on Transform Data. Alternatively, you can always go back to the Apply Transformations by clicking Transform Data in the Home ribbon.
Alright, Power BI has two main languages. On one side we have Power Query M, on the other side we have DAX. Power Query M has over 700 different functions and it's used in the Power Query Editor. Every action that you perform in Power Query Editor automatically creates Power Query M in the backend. It's used to transform data before loading it into your model in Power BI Desktop. The typical structure is it starts with a let statement followed by an in statement, as shown in the bottom. DAX, on the other hand, has over 250 functions and it's created in the report or the table view. DAX helps you create new information from data already in your model. It's kind of similar like Excel and we use it to create measures and calculated columns. Some common functions include calculate, summarize, year-to-date, or related. Below is also an example of a typical DAX function, calculate, where we look at the amount of sold items. So remember, we can load data and a pop-up screen will appear. We can either load, transform, or cancel. Transforming will open Power Query Editor and will allow us to make necessary calculations and modifications. In Power BI, we typically use two ways to store our data: the import mode or the direct query mode. Import mode imports the selected tables and columns into Power BI Desktop, and as you create or interact with the visualization, Power BI Desktop uses the imported data. refreshing the data will try to re-import the entire dataset again. Direct query, on the other hand, doesn't import any data into Power BI desktop. But as you create or interact with the visualization, Power BI will try to retrieve the data from the original source, and it's typically a live connection, for example, with a cloud database like Azure, or a typical web tool will use Google Analytics. It's limited to some data sources only. Now it's important to consider that the chosen option will impact performance. Direct query is less suitable when there's a lot of load time to get the data from the backend source, when there's a lot of users that will use the reports, and when there's row-level security on your model. That being said, there are some limitations to import mode. There's a 1 GB limit for datasets in Power BI service, and the scheduled refresh can only be done up to 8 times a day. Now, for our own models, we typically use import mode, as this is overall better for performance. Loading data through parameters. A parameter is an item of information, such as a name, a number, or a selected option, that is passed to a program by a user or another program. So it's kind of like a variable between different programs. Why bother about parameters? Well, it allows for easily changing environments, using and reusing values such as countries, categories, consumers, and the use cases are that you can switch between development, test, and production phase, and also apply dynamic filtering. Now it's limited to some data source connections, and often it will be used in an SQL context. Now, how do we set up a parameter? We go to Power BI, Power Query, and then firstly we have to enable the option Always Allow within the parameters field. We'll connect to an SQL server by defining the server and the database, and we'll set up the parameter by clicking on Manage Parameters. Within the field, we can indicate whether we want our parameter to be a text or any value, or maybe you want a list of values. So maybe you want colors, for example, and you want to be able to easily switch different colors. Now, it's important to note that this is not a full explanation because parameters is a very broad topic, but you can find more information in the Microsoft documentation. Next up, we'll go to Power BI Desktop and we'll click on Manage Parameters. We can change the parameters according to our needs. So, for example, if we want to switch between databases in this instance and sales year, we can do just that. So, quick recap, parameters can be used to easily switch data sources or environments and also values. They are listed in the query pane, and there are also some advanced options such as filtering a data source, logic statements, applying dynamic names to objects, and so on.
Power BI has a wide range of options when it comes to connecting to different data sources. We can load data in both the desktop view and also the Power Query Editor view. Let's take a look at what the different options are. So we can click on Get Data, or we can go on Recent Sources. When we click on Get Data, we get a pop-up screen of all the choices available to us. You can see that there's a lot of options. So we have files, we can connect to databases, to Power Platform, to Microsoft Azure, and also to online services such as Google Analytics or SharePoint lists. When we decide to connect to a database, we close this for now, we get a pop-up screen. We get a pop-up screen asking us to either load the data immediately into the desktop view, or we can also transform the data. When we click on Transform the Data, it will open the Power Query Editor.
When loading data into Power BI, we want to verify that our data is usable when we're creating reports and that it doesn't contain any missing values or that data types are not captured correctly. When opening the Power Query editor, you'll have a range of options under the View tab in Data Preview. The most important segments are column quality, column distribution, and column profile. They can give you more information on the distribution, the uniqueness, or the number of errors in a certain column. Note that these options give you information on a column base, not on the entire dataset. Now, knowing which segment does what is quite important, so try to remember the names and their respective function. When clicking on column quality, you can see what number of values are valid, are empty, or contain an error. When clicking on column distribution, you see distinct and unique values, which we'll cover later on. Column profile has a wider range of options, and it's basically a summary of both column distribution, column quality, but also some additional numerical information. A quick recap here. So we have the option to show errors, show valid data, show empty values in the column quality, and the column distribution will show us unique, distinct values and also give us an idea what the distribution looks like. Column profile contains all of the listed details. Now we also have monospaced and show whitespace. Monospaced displays the options where each character has the same space, and show whitespace is a way to visualize whitespace in data cells. Now, we've already talked about unique and distinct values, but what's the difference? So we have a column profile here that says, okay, you have unique and distinct values, but let's take an example. Right? So we have a short example here: red, jade, cyan, magenta, and another times cyan, so 2 times cyan. Now, unique values, they appear only once, while distinct values is the number of categories, let's say. So cyan is not considered a unique value because it's listed twice. However, it still counts as a category, so if the number of distinct values in this case is 4. Next up, merging versus appending. So we can combine our data in Power Query Editor by either appending queries or merging queries. Appending queries is joining tables together by adding rows. As displayed in the picture, we have one table above with the same columns on the bottom, and then Power BI will just add those 2 rows together. You have 2 options. You can append queries or you can append queries as new. It's important to know as well that you can also append a lot of different tables if you want to. If you have 10 tables in the same format, you can append all 10 of those. Merging queries, on the other hand, is a bit more difficult because it has a lot more options. Merging queries is adding 2 tables or more into columns, so you're basically adding the columns together to the right instead of on the bottom because the columns don't always match. Now, in this case you also have to specify a join kind. There are a number of join kinds displayed, and we'll cover these in the next segment. So we have 6 types of joining. The left outer will use the values from table A. It will reiterate this, but it will only take the matching values from table B. Same goes for right outer, but in this case it will only take the values from table B and the matching values from table A. The full outer will not delete any information, but it will keep all the data and it will add all the cells together where possible. An inner join is a way to only keep data that matches or that's the same between both tables. The left anti will only keep the values that are not in the other table. So it will not include the values which are presented twice. Left anti, because in this case it only keeps the values from table A, the left table, and right anti will only keep the values from table B. Right, so next up is transposing, pivoting, and unpivoting data. Now, before we go into the theory, let's first look at what we're trying to accomplish by using an example.
In the first example, we want to have the first row as the first column, as we want to be able to evaluate the different companies. Our transpose function will give us the required layout. But note that this function transforms the entire layout. So now we have the companies listed in one column and then also the employees and the location. We just need to change the fact that the first row actually become the headers, and we can do so by using this function, use first row as headers. So now we're all set to perform our analysis. Let's take a look at another example of the pivot and unpivot function. So in this case, we have stores in one column, we have category in one column, and then we have all the different years spread across the table. Let's say that we want instead to have the years in one column and the sales value, in this case these numbers are the sales values, in another column. We can do so by selecting those two columns, then going to transform, and then unpivoting the other columns, because those are the columns that we want to have displayed differently. Alright, so now we can see that we have the years in one column and values in another, and we can easily perform multiple analysis based on this dataset. Let's say we want to repivot our data. Maybe we want to perform an analysis based on the sales amount per store. So how much did Amsterdam stores sell in 2016 compared to 2017, not taking into account the different categories. We can do so by duplicating this column. We will delete the category column as we don't need it. Then we select the store and we go to pivot. So pivot column, a window will pop up and it will ask us where are the values stored. So in this case, the values are stored in the value column, and we can also indicate what kind of aggregation we want to add. In this case, we want to have the sum. Click OK. And now we can see the different stores as headers and the different years as rows. So we can compare, for example, the first year Amsterdam performed the best out of those three, and the second year it was Brussels. So that's it. Let's move on.
Alright, so let's do a quick recap of what we discussed. So transposing is moving columns to rows for the entire table. Pivoting is changing rows into columns, and unpivoting is changing columns into rows. Alright, let's move on to the next topic.
Data types are a really important aspect of working with datasets. Power BI automatically tries to link each column with the correct data type, but depending on your data source, you might have to make some manual adjustments. Most of the time, this is done in the Power Query editor. Data types are changed in the Power Query editor under the Transform ribbon and then going to data type. You can change the type to decimal number, whole number, date time values, and also duration text and binary values. It's important to note that if you select datetime here, that Power BI desktop will automatically display a hierarchy for this value, but we'll discuss hierarchies in a later stage. Now, what about handling blanks, empty strings, and zero values? Let's say that I want to change this column to a numeric value. Now it's not specified. Let's say that I want to instead change it to a whole number because I want to perform some analysis later on. It gives me errors because it cannot convert this text to a numeric data type. Now, if I want to change this error, I can go to replace values and then replace errors. It will ask me what kind of transformation I want to perform on the error values. Let's say that I want to change it to the value of 1 because it should display that the quota has been achieved. There we go. Now I can use this filter in a later stage to make an assessment whether a certain store and category has performed according to their quota. Now, this was an example of a cell error. There's also a second kind of error called step level errors. These type of errors prevent the query from loading and display the error components in a yellow pane. Examples include my customer table, where it says it cannot retrieve the correct source. Another common data source error occurs when Power BI cannot find the column you reference to in a certain Power Query M code. Alternatively to replacing errors, you can also change values in this segment. So you have the replace error segment and then also the replace values. For example, if I want to add words but change the name of words to a certain version, words updated, let's say, I can do so and it will adjust the layout for the entire table. This is also very helpful to retrieve, for example, spelling errors. All right, so we identified how we can evaluate and transform data types. Let's move on. Next, we'll also look on how we can add or delete columns and rows. Let's go over the different options. We're still in the Power Query editor, as this is where the main transformations happen. Let's go to the associated product table. Deleting one or multiple columns is done through the Remove Columns option, which can be displayed accordingly. Now, adding columns, there's multiple ways. So you have the column from examples, you have the custom column, invoke custom column, conditional index, and so on. We'll start with the column from examples. In this case, we just have to write what we want, and Power BI will recognize it and also perform all the transactions or the transformations for every row. Let's say I want to add Microsoft to every product. I'll just click Microsoft Access and then press enter, and I can identify that it correctly displays what I want. So I'll click on OK. Next up is the custom column. Custom column allows you to write the Power Query M code directly and also work with tables. Let's maybe say I want the same as before, so I'll write Microsoft and specify that it's an integer, so I put it between brackets, and then I'll add I'll do it like this, and I'll have the product. So it doesn't give me any error, So I can press OK, but I'll also add a name to it, merged to. There you go. Now, the third option is invoke custom column. So this is another option where you can specify a custom function defined in the file for each row. So you have to add a function query because we don't have any function queries. It's empty for now. Another method that we'll discuss is the conditional column. So in this case, you can add if statements like you would in Excel. Let's move over to the products table and illustrate this by an example. So here you have the products according to price. And let's say that I want to indicate that any products that have a price above 50 should be in the premium segment. So I'll add a conditional column. I'll add its header name, premium. So if the product equals, if the price is less than or equal to 50, it should be 0, and otherwise it can be 1, indicating it's premium. Clicking on OK will give me the correct result. Now, I didn't include 50 into it, so it will start from 51. All right, an important feature to remember is that for performance reasons, it's better to add columns in the Power Query M editor than using calculated columns in the desktop view. However, the exercise we displayed here could have also been achieved through a measure or a filter. Now, the final thing that I wanted to discuss was the index column. So an index column is a very useful feature for adding a row counter to your data set. So I'll just click on it and you can see what it does. It starts counting every row. This is useful if you want to perform advanced analysis. Now, we can also add or remove rows instead of columns. This is done through the Home tab, where we can keep rows or remove rows. So we also have to specify the number. Let's say I want to keep 15 rows, then it will delete the ones after that. Okay. We can also indicate which rows we want to remove on the bottom, or maybe we want to remove duplicates and so on. All right, so we've looked at how we can add or remove columns and rows. Let's move on to the next segment. An important thing to note is that everything you do in Power Query Editor will be shown as an applied step on the right. The applied steps are all the transformations that you apply to the data, and they are shown in their respective order. So the first thing we did here was load the data through a source and change the type, replace a value, and add some columns. Now, it's important to note as well that in the advanced editor, we can see these steps as shown in Power Query M code and also perform relevant modifications. So when opening the advanced editor, we can see our steps applied using Power Query M code, and it has a typical structure. So it starts with a let statement and it's followed by an in statement. Now, the Query M language is a very extensive language with over 750 functions. Let's go over to the Microsoft Docs and see what kind of functions there are. Taking a look at the Microsoft documentation, we can see a variety of functions. So we have functions for data, binary functions, we have duration, lines, logicals, and so on. In fact, there are over 750 different functions. Although you shouldn't know all of these, it's worth looking at some of the common used ones. So let's go back to our slides.
Alright, so this was the first big module, prepare the data. So we got to understand the difference between Power BI Desktop and Power Query Editor. We also looked at import and the way to which we store data using direct import or direct query. We briefly covered parameters. We looked at data profiling to column distribution, column profile, column quality, and so on. We've also used a couple of built-in functions within the Power Query Editor. So we've looked at merging or appending our data sets. We've also looked at built-in functions such as transpose, pivoting and unpivoting. And then finally, we've used how we can leverage the advanced editor to make our model even better. Up next is modeling our data using the different functionalities.
Alright, we're in Power BI Desktop and we want to see our relationship structure. We can see that it's quite complex. So we have a lot of different tables and they are connected by these lines. The lines, they represent the relationships. You can also see that there's a 1, so a number, and a star. This indicates the cardinality type. In this case, it concerns a one-to-many relationship. In this case, it's a one-to-one relationship. We can also see that there's an arrow. The arrow indicates that the store table is filtering the sales table, and the cross-filter direction is set to single, while in this case, it's set to both. Notice also how when I hover over a table, we can see the name, the storage mode, and the date at which it was last refreshed. That's it for now. Let's go to the next segment.
Alright, in this segment, we'll look at how to design our data model. We'll define the relationships, hierarchies, create measures, and derive insights from our data using visuals. First, we'll look at how we should structure our model for optimized performance and usability. Data modeling is an important aspect of data analysis. A good data model contains the right number of tables with the right relationship between them. Setting the correct relationship between the tables in a data model is important because the relationships decide the direction of filter propagation in Power BI. A star schema is an example of a data model when you design the data warehouse, and it's kind of best practice to have a star schema whenever possible. It allows for better performance and also it's easy to visualize, and it's also easier to use DAX functions later on. Now, what is a star schema? Well, we have dimension tables and we have fact tables. The dimension tables are those on the outside, so those typically contain customer data, product data, store data, values that appear only a few times and ideally only once. Then in the middle, you have our event data. So we have our transaction data, our sales data, which also references to the products or the stores and so on. Now, if you use your imagination, we can configure a star in the middle, and then we have our dimension tables and our facts table. Now, why would we use a star schema? As said before, usability, performance, and also faster refresh. The common steps in designing a data model are typically the same. We'll select and configure our data source, we'll load and transform our data, we'll set up a data model, we'll configure relationships, create measures and calculate columns, introduce visuals, and then derive insights. Alright, let's move on. Now, I've already quickly mentioned filter propagation. Now, filtering is done through visuals, and the underlying tables, they are connected using relationships. This process is called filter propagation. The filters start propagating or moving from the dimension table towards the fact table. In this case, if we wanted to know the sales quantity of product category A in calendar year 2018, we would use a specific measure. And Power BI would first use the dimension tables to filter the data and then get the information it needs from the sales data. Now, when we have our response, we can display it in a report. We can use a simple card visual or another visual, whatever we like. Now, when we discuss relationships, cardinality is a really important aspect. There are three options: one-to-many, or many-to-one, one-to-one, and many-to-many. One-to-many will take one value in a table and match it with multiple identical values in another table. So the one in this case will be the dimension table, the multiple will be the facts table. The most common type of cardinality as so I've already covered this. So dimension table, filtering the fact table. Now, best practice is also to keep our tables narrow and long instead of wide and short. So better to have little columns and a lot of rows instead of a lot of columns and a small number of rows. This is better for our performance and other reasons. Now, one-to-one is when we have one value in a table that has another value in or another single value in another table. It's used in specific scenarios such as a degenerate dimension from a fact type table or multiple data sources for a single entity. Now, when possible, it's better to avoid these and use merge or append functions whenever possible. Finally, we have our many-to-many relationship. So we have multiple identical values in one table that match with multiple values in another table. It can be useful in some scenarios, but it's best to try to avoid this whenever possible. Summarization and other numerical functions might not always display the correct results, so keep that in mind. Alright, let's move on. Now, next up, active and inactive relationships. So some data models might initially require you to link to the same column in the fact dimension table twice, and in doing so, you automatically create an inactive relationship. So what does it mean? So an active relationship is, for example, in the picture below, there's between arrival airport and airport, but then there's another relationship between airport again and departure airport. Now, it makes sense because often the arrival airports will be listed in the airports table, but also the departure airport will be listed in there. Now, in this case, we might want to use functions that, or we could use functions that also call the departure airport, but it's typically best practice to have two tables instead. So in this case, one for the departure airport and one for the arrival airport. Note that these are duplicate tables. So our dimension table on the right is duplicate, and now the relationship is active. So we have two active relationships instead of one active and one inactive. All right, let's move on. Cross-filter direction. We've already discussed it, so it's the arrow, and it's automatically often dependent on your cardinality type. So in one-to-one, you won't have any option. You will have to have both as cross-filter option. In some cases, you have the cross-filter option to set to both. Now, what does it mean? Well, both means that it filters in both directions, and it's also something that we describe as bidirectional. Modifying the relationship can be done in a cross-filter function, which is a DAX function. Now, in this case, we have a model that uses a bidirectional relationship, as you can see by the double arrow. Now, the presence of that bidirectional cross-filter introduces ambiguity in the model, which is a problem that often occurs with bidirectional relationships. Now, what is it? Well, it's a case where a model is a bit struggling or has potential issues that may arise because of the way the data model is set up. In this case, the problem lies in the fact that the date can be accessed through the purchase table, or it can go from sales to product to purchases, or it can go directly from date to purchases. So this is a problem here. You have two ways to retrieve and fetch your data. Now this can be dangerous as it may cause your model to break, especially when we're introducing filters. So the general conclusion here is to avoid using bidirectional relationships whenever possible.
So we've loaded the data in the Power Query editor, and now it's time to further develop our model. We can easily add additional calculations using measures and calculated columns. These are very often used in Power BI as they allow us to extract information from the underlying data and help us make relevant numerical calculations, such as sums, divisions, create percentage changes, track changes across years, and so on. After creating a measure or column, it appears automatically in the fields pane. The fields pane is displayed here, and you can see that there's a bunch of different icons to the different columns. So this represents a table. Underneath it's a date, which indicates a calendar, this icon, and the item below that indicates a hierarchy. So a hierarchy is a set of sequential columns that are based on a logical order. This icon represents a calculated column, which we can add to the modeling and then new column. We can also add measures and they will be displayed through a calculator icon. To create all of these, simply hover over one of the tables and click New Measure, New Column, New Quick Measure, and so on. It's quite important to understand the difference between a measure and a calculated column. A calculated column will create a new column for your model, and it will add cell values based on the function that you specify. A measure, on the other hand, won't do that. A measure is like a function that you create, and it returns the results in a visual, but it will not populate any cell values in a new column. The choice between a measure or a calculated column also has an impact on performance. The storage will be larger when you use a calculated column, so also likely impact on performance. But on the other hand, a measure might be harder to compute if you want your visuals to load really fast. Generally, measures are more useful, but the trade-offs are the performance hits, storage space, and the type of expressions you can use. For example, calculated columns are often used when you want to filter on the result rather than just a calculated result. Also, in the context of slicer, you might want to opt for a calculated column instead of a measure. Measures can be created in two ways. We have quick measures, where we can add some quick calculations such as a sum, averages, year to date, running totals, and so on. or we can write our own measures using DAX formula. By clicking on New Measure, a window will pop up, and I will be able to code the DAX myself. In this field, I can reference to tables, to columns, or to values. And then afterwards, when I created the measure, it will be added here in the Fields panel. This might be a lot to take in, so let's do a quick recap of what we discussed.
Alright, so let's do a quick recap of what we discussed. We have calculated columns, measures, and hierarchies. So calculated columns is Power BI Desktop, which uses DAX, and it creates a value for every row. Versus a measure, who only creates a single calculation. A measure is a sort of data transformation, but it won't create any additional columns in the Power Desktop dataset. It also uses DAX, and you can write it yourself in the formula pane, or you can use quick measure in the fields pane. A hierarchy is a combination of columns in a logical order. In this case, we have a region, product category, and a product subcategory. It can also be a date, which starts by year, month, day, and so on. It's detected automatically in the case of dates, and it's very useful in reporting and drill down functionalities, which we'll cover later on. Alright, on to the next section. Now, we've already looked at some DAX functions. We looked at calculate before, but some other common functions which you should take the time to truly understand. Among some common functions is the group by, summarize, stop and, cross filter, and so on. So you have statistical functions, you have logical functions, you have date functions, you have functions that are used in relationships, such as the all selected, the related, the use relationships. So all kinds of different functions with different functionalities, and it's truly important that you know these functions and that you can use them. Now we also have DAX statements. So these are var, define, evaluate, and order by. These are used in specific scenarios. An example of a DAX function is if you want to look at the last year's sessions on our website, you would use calculate, and then you would say which column it has to sum. The sum is default here, or the sum is optionally here, I would say. And then we have the filter criteria, so we have same period last year and then the date. Now, popular challenges for specific DAX formulas include SQL BI, Gynicube, and also Kerbal. Variables are specific DAX formulas that allow you to introduce some complex formulas to your model, while not making the formula too long, but instead using variables as a way to improve the readability, the complexity, and the performance of your function. So in this case, we had a function that follows a lot of different functions after each other, like you would see in Excel, but with variables, we're able to write much more cleaner code, and it looks better, but it's also more powerful, more performant, and it has less complexity from a reader, but also for you as a data analyst. Quick reference guides to the icons used in the desktop. When you're working with Power BI, you'll come across these when you're working and building your models, but yeah, I won't spend too much time on this right now.
Besides the common functions shown previously, the DAX documentation guide covers around 250 different functions. There are date and time functions, filter functions, you have financial functions, and many more. That was the overview of the different DAX functions. On to the next topic. In this segment, we'll discuss the core of what Power BI does, visualizing the data and deriving useful insights. In Power BI Desktop, next to the Fields pane, you have the Visualization pane. So here we can choose across a number of different visualizations. We can also load additional visuals, either certified by Microsoft or from third-party developers. Notice when I select a visual that it will have either 2 or 3 panes. So we have the Fields pane, where we put in our data, axis, legend, values, and then we have the Layout pane. In the Layout pane, we typically adjust the formatting, and the final one is the Analytics pane. The Analytics pane has a lot of interesting features, such as a forecasting feature. You can also add trend lines, percentile lines, constant lines, and averages. So that's it for the different panes in Power BI Desktop. On to the next topic.
Alright, so the common visuals in Power BI are listed below. We have line charts, which we all know, but also we have cards or funnel charts, waterfall chart, tree maps, we have a lot of them. So it's important to know what visual we want to use for our specific function, for our specific situation, because each of them has their own functionality. Now, a line chart will probably or likely present data over time, and it puts an emphasis on the overall shape. Bar and column charts, they show the data across different categories. A combo chart is a combination of both a line chart and a stacked or a regular bar chart. We also have donut and pie charts, which show the relationship of parts as a whole, or to a whole. A simple card can be useful for representing a number. Funnel charts are really cool visuals that usually display a process with stages where items flow sequentially from one stage to the next. An example includes a sales process from leads ending with fulfillment. Next up is a waterfall chart, also a very cool visual, often used in a business context to get from revenue to profit or from revenue to EBITDA. Tree maps are charts of colored rectangles with sides representing value. They can be hierarchical, with rectangles nested within the main rectangles. The gauge chart displays the current status of the context of a goal. The the key influencer chart shows the major contribution to a selected result or value. Last slide, the KPI chart displays progress towards a measurable attainable goal. A matrix is some kind of table, but it has multiple dimensions, and it also automatically aggregates the data and enables drilling down. A ribbon chart shows which data category has the highest rank. So they're effective in showing a rank range or change, with the highest range always displayed on top for each time period. Scatter and bubble charts display relationships between 2 or 3 quantitative measures. A slicer is a very useful feature for making a selection and also allowing your users to make a selection, but we'll cover more on slicers in another segment. Now, dashboards are also an important feature of Power BI. They allow you to create a one-pager that has all the information that your user needs. So the way it works is that you create report, and then you can select what visuals should appear on your dashboard. So as listed here, it's built in Power BI Service. It can only be a single page where reports can be multiple pages. You create or you add data visualizations or visuals to a dashboard by pinning it with the icon displayed on the right. And it's important also to note that they don't have any filter, visualization, or field paints, and that the user also won't be able to see the underlying dataset. A very useful feature of a dashboard is that you can set alerts. For example, if a value should fall under a certain threshold. An alert can also be followed by an auto-generated email. Now, you can also set a dashboard as featured, which means that it's often approved by a certain admin, and it's usable for a wider context within your organization. Now, this isn't an option for regular reports. We can configure data alerts on a dashboard tile by going to our dashboard and clicking on the three dots, and then selecting the bell icon, adding an alert, and then configuring the alert. You can also add a send me email to checkmark, and then we will also automatically receive emails as soon as the threshold is hit or the alert is triggered. All right, let's move on.
In Power BI Desktop, filters are an important part of Power BI. In the report builder, we can decide what data needs to be included and what data isn't really relevant to show. The basic filters are shown automatically for the columns and the measures that we selected in our report. Let's say you want to change certain elements of a visual. For example, it might be relevant to show only the best performing categories by sales value using the top N filter type. Doing so, I press the store breakdown, and then the store, which is currently unfiltered, I select the top N. And let's say I want to investigate the top 5 performing stores. So I say top 5, and then I have to add a field to evaluate it. So we add the return field, and then we apply the filter. So now we can see that the stores, or only the best 5 performing stores, are shown. And also, the category is now being affected by this. We'll quickly discuss edit interactions as well. When we click on a visual, it will take some time here, we get the format option and we can edit the interactions. This way, 3 icons appear: filter, highlight, or none. In this case, category breakdown is set to highlight, store breakdown is set to filter, and the Q&A feature is set to none. Now, let's see what happens if I change this. So in this case, I will add the default, which is the filter. And the default basically says that if you indicate a value by clicking on it in one visual, it will also indicate or impact the other visuals across the page. So if I click on Pharma here, the category breakdown will only show me the results for Pharma. Notice that the Q&A visual did not change because it's set to none. Nevertheless, it still refreshes. Let's say that I want to highlight instead of showing only the results for my store. In that case, I press this button, and only the Pharma results are shown as part of the total. If I don't want to apply any filters and keep my visual unaffected by any other visuals, I click on None. Let's talk about another important element of Power BI, slicers. You can empower users by introducing slicers. This way, they can choose what data they want to see. For example, it might be useful for them to allow them to see values by dates, categories, regions, and so on. If you don't want a visual to be affected by a slicer, remember that you can change this by going to Edit Interactions and clicking on the icons. Let's say we received a request from our marketing analyst and he wants to evaluate the results of a marketing campaign across 2 weeks. So in this case, we could add a slicer featuring the 2 weeks and let him do the analysis. So I already added a slicer to our report, and now we just need to go to date and add a field. And in the filter, I'll make sure that he can only select the 2 weeks that are relevant to him. So let's say that those 2 weeks are the ones that we need. And now we're all set. So he can choose between this one, these dates, and also see what the results is in the other week. But the fact that I changed it to a couple of weeks here made it a bit difficult, but you get the point. You can also add hierarchies to this selection, and then users just have to check mark certain selections. So slicers are a really important feature in Power BI. It's important to note that slicers only affect the page that is currently shown. If you want a slicer to affect the entire report, you can change this by going to the View tab and clicking on Sync Slicers. That way, a window will appear asking you which pages it should sync the slicer on, and also whether we want to display the slicer or not. Alright, that's it for this segment. On to the next one. The next thing we'll discuss are bookmarks and tooltips. Bookmarks, available under the View tab, allow you to freeze a certain visual, which can be useful when they're really complex visualizations, or maybe you're giving a presentation and you want to focus on certain things. So it captures the information that's currently shown and it saves that for later use. So let's go to the documentations for this one. Creating bookmarks, as I said, is done in Power BI Desktop, and you can create a collection of them and arrange them in any order you want. You see that it's often relevant when there's a lot of complex visualizations and you're giving a presentation and you want to quickly be able to solve any questions or show any interesting visuals or let people ask questions and revise later on and so on. The selection pane also lets you set which bookmarks should be shown, what should be hidden, and so on. And you can also have bookmarks for shapes and images. I don't think the rest is really interesting, but yeah, you can go ahead and check out the documentation for this one. Also for tooltips. So tooltips are a way of providing extra information to your users when they hover over a report. And they are created by going to another page and creating a visual and then connecting it to another visual on your report. So in this case, this visual is featured on another page. But you can see it's really useful because it's hard to do any analysis based on this one, but this already gives us a lot more information. Again, check out the documentation guides for this one as they are smaller segments. Alright, that's it for the layout. On to the next one. Another cool feature of Power Desktop is the drill through option. Drill throughs allow a report user to access the underlying data of a report. Setting drill through is possible in both Power BI Desktop and Power BI Service. In this case, if I want to evaluate the store performance by the different date, I can do so by clicking drill down, and then it will show me the performance across the different weeks starting on Sunday. There are also a lot of tools that help me to show where I currently am in my drill through, so I can use these to navigate across my reports. Now, we won't discuss the setup in detail, so I highly recommend you check out the drill through documentation guide from Microsoft. Just knowing when and how to set up a drill through will be sufficient. All right, that's all for the reporting tools. On to the next section.
So what are paginated reports? Well, paginated reports are structured documents that are used for often a business context and to be able to retrieve information from a database and to display it in a structured template, structured format. It's built in a different application than desktop, so it's built in the Power BI report builder. It also requires a Power BI premium license, and it allows you to also set a deployment pipeline, so development test production, before you release any paginated reports to your users. To set up a paginated reports, we start by choosing our source. So in this case, we're connecting to an Azure SQL database, and we get a preview of the data and we select what tables and fields we want. And then we can start drag and dropping certain items and start creating our paginated report.
Paginated Reports is a separate application in Power BI. They allow you to create all kind of standard reports, and usually it's created in a business context, for example, to create invoices or other structured documents. Paginated reports are built within the Power BI report builder. It's a separate application which you can download by doing a quick Google search and then going to the install center. They look like this. So you have this report builder, and then you can create all kind of templates and then also publish them to Workspace.
Alright, so that brings us to the end of this section on how to model our data. We've covered quite a lot of ground. So we've identified what a star schema looks like. We can now configure relationships and also cardinality. We can add cross-filter directions. We know the difference between uni and bidirectional relationships. We can also add measures and calculated columns in Power BI Desktop to our report. And finally, we can use these calculations in our reports or dashboards by adding visuals that suit our data best. So next up is analyzing the data, where we'll first look at how we can increase our performance. Now this is actually a section that was discussed according to the content outline all the way in the beginning, but we've decided to cover it now because it builds on some of the concepts we've already covered. All right, let's look at analyze the data. Performance is really important when you're building your data model and creating reports. We have 6 golden rules for optimized performance. First one is the sooner that you can resolve a potential performance issue, the better. For example, use custom columns in Power Query Editor over calculated columns and try to fix any performance issues in Power Query Editor instead of adjusting it through filters or slicers when you're creating your visuals. Also, avoid using wide datasets. Datasets should be small in width and long in length, so a lot of rows and a small number of columns. Ideally also use star schemas for relationships. Now, don't overdo the number of visuals or tiles on a single report, as this also may cause performance issues. Use measures over calculated columns whenever possible, as this reduces compute requirements. For datetime variables, try to split the date and the time into a different column if you need it. Otherwise, this is takes quite a lot of compute power from your model. Alright, let's move on. Now, how can we analyze our performance? In Power Query Editor, we can go to the View tab and click on Performance Analyzer. Here, we get an overview of, first we need to select our site, our location, and then we get an overview of the different performance issues and load times. Yeah? So in this case, you see that it takes quite a long time to load a button, but the DAX query only takes 4 seconds. So yeah, this is just a great way to analyze what is causing delays in your report. We can also look at potential issues when we load our data. So what happens if our query is the thing that's making our reports run very slowly? So in the Power Query Editor, we go under the Tools tab, we have the option to perform a diagnose, so query diagnostics. Doing so will create 3 queries, and they will have a lot of information on the different load times of your data and where potential issues might arise. So they will help you understand what Power BI is doing when you refresh a dataset to identify performance issues and identify what queries take the most amount of time. So this is a feature that you have to enable in the options. So query diagnostics, you can enable it in Report and Query Editor, or only in Query Editor running as admin or not. Alright, let's move on to the next segment.
Alright, so back to our visuals. So what can we do to increase the value for our users? Well, we can add certain analytical tools or also change the layout. So we've covered these panes already, but now let's go a bit more into detail. So the analytics pane has all kinds of analytic and numeric functions, such as adding a minimum line or a maximum line, or even adding a percentile line. So in the example here, I added a percentile line for the 85% of all cases. It can be used in a business context or just when you're performing a certain study. The forecast feature is also a very cool feature. It allows you to extrapolate on the previous data and look at possible ranges of where your next observation will be. Another cool feature is the anomaly detection. So this feature allows you to detect certain anomalies, things that aren't really in line with the rest of your data. So you can imagine this being really useful in, for example, an anti-money laundering context. Now, next to the analytics pane, we also have the layout pane. So in the layout pane, we can change the formatting of our visuals. So for example, formatting the title, the columns, the X and Y axis, how our data is shown, and so on. All right, that's it for these elements. On to the next section. Alright, next up is AI Insights. So there are a number of advanced tools that you can use to empower you and your report with the latest AI, artificial intelligence functionalities. We have text analytics, vision, and Azure machine learning. Text analytics has 3 options: sentiment analysis, where there is a certain sentiment that's being analyzed. This is often words, so a consumer gives a review, and then the model will scale this review from from 0 to 1, 1 being positive. And then it's useful to extract additional analysis on social media reviews and see what the overall feedback and sentiment is. Next up is key phrase extraction, which will extract the key phrases out of a certain long document. So it will give you a summary of what the document states. Another example of text analytics is language detection. So language detection will return the language that's being used in your document. Vision is, for now, it's only image tagging. So image tagging, as you know, the model is shown pictures and then it has to correctly identify certain text associated with it. So cat or dog or a background. And of course, there's a lot of use cases in practice. Lastly is Azure Machine Learning. So you can also connect your own machine learning models and incorporate them into your report and reuse the already done models that you created. So to sum up, Power BI is already doing a lot to have the state-of-the-art API capabilities in there. It's configured in web service or in Power BI query editor, and it requires a premium license. The smart narrative visual is a way to quickly summarize visuals and reports in text form. So it provides relevant, innovative insights that you can also customize. For example, in this case, we have 4 visuals on the left, and they get explained in detail with actual numbers on the right. And on the right, the key insights are extracted. There are some limitations though, so it's currently not supporting pinning to a dashboard, publishing to web. You can also already or do it for some visuals for now, and there's also no option to cross-filter on this smart narrative visual.
Alright, so that's it for the section on how to analyze our data. So we've started with performance, and then we've looked at the analytics and the layout pane, and we ended with some ways in which we can empower our visuals using advanced analytics and AI functionalities. Up next is deploying and maintaining our deliverables.
So we've looked at how to analyze the data. Now it's time to also figure out how we can deploy and maintain our deliverables. So it's important that our users always have the latest data available. Now, how do we do that? Typically, we do so by having a refresh functionality to our report. Now, before we get into refresh, we need to explain a couple of topics in detail first. So we've already covered the different storage modes. We covered import and direct query, and you also have live connect and push, which are used to a lesser extent. Now, regardless of the storage modes, there's no option to have a data refresh succeed unless the underlying data sources are accessible. There are 3 main data access scenarios, so either it's located on premises and you refresh that way, either it's on cloud or a combination of both. Now, depending on your storage mode, the refresh will happen in another way and it will also have other functionalities. For example, if you use import mode, a data refresh can be scheduled and on demand, but for direct query, it's not applicable because your data refreshes, the way you set it up typically, or by default, it's every hour because there's a live connection between your data and your data set used in your report. Now, there's also other kinds of refreshes. So you have data refresh, query catch, and tile refresh, and then also visual refresh. So query cache is when you have a certain query and the results are remembered by the desktop functionalities, and that way it can easily retrieve the same results should the query be loaded again. So this is always the option to be enabled or disabled, and it's a premium functionality. A tile refresh, which you use in a dashboard, happens automatically when you perform a refresh of the dataset. Now your report, that's an important one. It will only refresh the visuals if you perform the manual action in your desktop or your mobile view. So in mobile view, it's scrolling down, and in desktop, it's using the refresh button. So the visual refresh happens automatically when live connecting, but typically you have to understand that mostly we will use import and direct query, and the visuals won't be refreshed as part of a dataset refresh. Next up is the concept of gateways. So if we use a data source that Power BI can't access over a direct network connection, for example, the cloud, or let's say Google Analytics is also a direct one, then you have to configure a gateway connection for this dataset before you are able to do a refresh. Examples include local files, datasets, and SQL servers. Now you have the options to perform or to deploy a personal data gateway or an enterprise data gateway. And it's quite easy to set up. So you go to the web service, then to settings, and then on datasets, you have the option to configure a gateway connection. Now you can look at it on the left here as well. So you have the different cloud services that can be accessed directly through the Azure Service Bus, and then you have on-premise data that needs to be connected through a gateway. Now, the typical order in which you will set up your gateway and the following actions. So you will start with the gateway, then you'll set credentials for the data to be accessible by the system. Alternatively or optionally, you can set a parameter, and then afterwards you can configure a refresh schedule. So for example, if you have a local file, you first need to set up a gateway before you can set up a refresh schedule according to that data. All right, so with data refresh, we've already quickly covered how it works in the previous slides, but I'll go again into detail here. So in Power BI Service, you also have the option to use a quick refresh now button, or you can use a scheduled refresh and then explain what's the frequency should be. So should it be daily, weekly, monthly? Keep in mind that under a regular capacity, you only have the option to refresh 8 times a day, while under the premium capacity, it's 48 times. Then in Power BI Desktop, you have the refresh button and also the incremental refresh. That's a way to have the refresh done faster when the data is quite large. It's quite an important topic, so I suggest you head over to the Microsoft Docs page for this one. Now, a dataset reset versus a page reset, we already covered. So Power BI won't refresh any report visuals when there's an automatic refresh. Now, for direct query, you can have the option to enable a refresh of your visuals, which is called the automatic page reset option, and this can be included through the layout pane. It can be a fixed interval or a change detection. So the fixed interval is just every X minutes. Change detection is when a certain change appears to your data. For example, a new row is added. Now, there are some limitations, as I discussed already. 8 refresh per day for the normal capacity, 48 refresh per day for the premium capacity. This is for the regular refresh. The datasets on the premium capacity with the XMLA endpoint enabled for read-write support, unlimited refresh operations and configured program. So this is basically saying that if you have a premium capacity that has a special connection with read-writes support, then there's the option to have unlimited refresh operations, but it's yeah, a smaller detail which you don't have to remember per se. All right, finally some recommendations by Microsoft. I'll quickly go over these. So schedule your refreshes for less busy times. Keep refresh limits in mind. So this is the data volume that's being loaded into your model. So if you do it too often, it can be quite cumbersome for your model and it will impact performance. Now, also verify that your data refresh time doesn't exceed the maximum refresh duration, because there's a maximum refresh duration, and if it takes too long, then Power BI will cancel the refresh. Optimize your data sets, that speaks for itself, and then avoid using DAX functions that test every row. So the sum x function, for example, is also not the best practice for performance reasons. Then limit the number of visuals on your dashboards and reports. And also, as a final hint or tip, ensure that Power BI can send refresh failure notifications to your mailbox. So that's an option that you can enable. All right, that's it for refreshing and gateways. On to the next topic. All right, next up is row level security. So we have to, in some cases, restrict our data sets and the way that the report is shown to some members, and we do that by using row level security. So in this case, certain people which are added to roles will be able to see a limited extent of the data. Now, in the left example here, we use DAX to specify that the role Eastern US can only see the values East in the column named region. So they won't be able to see any other rows that have another region specified in that column. We can also test our role if we go to View As and then we select our role. Now, two things also to keep in mind is that when using DAX, there are specific functions basically created for the purpose of adding more detail and granularity to our row level security. So these are username and user principal name. And this way we can select the username from when someone is logging in. We see the username, and then the data will only be shown if a certain value is met with that username in the column that you specify. So that way, if you have certain rows that can only be viewed by certain members of your organization, you can specify these members in a column, use DAX function to set up row level security, and then those members will be able to see the specified rows, but the others won't. All right. Username returns a name with a domain, and user principal name looks like an email address. A final thing to note is that you create roles in desktop and service, but you assign users or groups to roles in Power BI service only. So this is not possible in desktop. All right, next up is adding sensitivity labels to our data and our reports. So we can increase our security, or at least make our users more aware of any confidentiality issues that may arise by using those labels. You can set it up by going to settings and then in the sensitivity section choosing the appropriate label and then saving. And this will make sure that when users think about sharing any documentation, that they get reminded of the fact that some things shouldn't be shared to other users or members outside your organization. All right, next up is endorsing through promotion and certification. So you can promote a certain report, which means that coworkers can easily use that document and are also supported in doing so. It's easy to retrieve promoted documents, and then anyone can basically that says so he or she creates a report. If they think it's something that a lot of users will use, they can opt to promote that content and allow coworkers for easy retrieval. Certification, on the other hand, is a way in which authorized users indicate that a data set meets the organization's certified criteria. So this could be, for example, it's that the underlying data isn't confidential by any means, and it can be used by anyone within the organization. You can configure it in Power BI Service for datasets, data flows, reports, and apps. Now, in some cases, you have very large datasets, and this might impact performance. Now, if you're on a premium capacity, you can enable the large dataset storage format, which will make sure that your data loading and also your limit is set so that it's able to handle large amounts of data volumes. So it's required for datasets if they grow beyond 10 gigabytes per users, but it has additional benefits also with regards to specific functionalities. You set it up in the web service. If you go to datasets and settings, and then you enable the large datasets, and then you can also do it in the workspace by going to settings and then premium. They all speak for themselves. So important to note here, you have the option to enable the large datasets format. All right, on to the next topic.
Next up is workspaces. So workspaces are places where you collaborate with your colleagues or other members of your organization. So it's set up in Power BI Web Service, and you can use Workspace to work together and cooperate with colleagues. Typically, you start by creating your report in desktop, and then you publish it to Workspace through the publish button on the bottom left here. So you have workspace assets, you have reports, datasets, dashboard, paginated reports. Now, ideally, a workspace should have some logical structure. For example, it can be for a certain project, or it can be a workspace for a certain department. And within that workspace, you can then add users to your workspace who can change reports, use reports, publish reports, and so on. Now, there are a lot of different functionalities here, but I won't go into detail of those. Let's instead look at the different roles within a workspace. Now, as I said before, workspace asset access is set through roles. So you have the admin role, the member role, the contributor role, and the viewer role. It's important to understand the difference between these roles. The admin role is the most high-level role, and he's responsible for organizing access to the workspace and configuring the access settings. The member role is kind of like the admin role, but he or she can't add or remove people from the workspace. The contributor role can be configured as a member role with limited access to some functionalities as well. It's important also to note that the contributors can update an app, which we'll cover later on, and if only the workspace admin delegates this permission to the contributor. Now, it's also important to know that they can't publish a new app or change who has permission to an app. A viewer role allows read-only access to the content. So users with a viewer role can also export data if they have built permissions on the dataset in that workspace. I'll quickly go over to the notes. So we discussed the contributor role. Now you also have the reshare permissions that you can enable. You can also have build permission for the dataset, and that allows you to copy reports or to create a report based on a certain dataset in a workspace. Now you also need to keep in mind that you need to set up the permissions on the gateway as well if they want to have refreshes or they want access to the underlying data. And then also finally, if you don't have a Power BI Pro license, you can view and interact with items in the Power BI service if it's under a premium capacity. Alright, so the right table sums up these different roles. Again, it's important to understand the difference between these roles. Next up is deployment pipelines. So deployment pipelines are a feature within the web service. So here it's often in the context of a product or a model that you're developing, and you have your test phase, your development phase, and your production phase. So development phase obviously coming first, and then you create different workspaces for these different phases. And then you can also have test data in your development phase, but actual data in your production phase. And you can create different kinds of access and different kinds of roles within each phase. So this allows for not only working together with different teams, but also just a better overview and control over your production pipeline. Lastly, it also allows version control when you set it up through with OneDrive that it auto-syncs. Okay, that's it for deployment pipelines. What's up next? Data flows. So data flows are a reusable process in which the data is collected using multiple data sources and allowing reusable transformation logic across datasets and reports inside Power BI. Basically, it's the ability to reuse datasets in a structured way. Additionally, it can also serve as a way to prevent data analysts from having access to the underlying data source. On the right here is an example of how the structure looks like once you want to set up a data flow. Also, maybe for your information, a common data model here is a shared data language for business and analytic applications to use, and it makes it possible for data and its meaning to be shared across applications and across business processes. So data flows a reusable process in which you can retrieve data but separate the usage of the data from the underlying data permissions. All right, next up is configuring and updating an app. So applications are typically connected to a workspace, and they allow for broad distribution of your content. And so distributed to broad audience is done through an app. Apps are created in workspaces or from workspaces rather in Power BI service. You can collaborate with your colleague in the workspaces, and then you can publish the final report to an app. The steps are as followed. So you create a workspace and add reports and dashboards, and in the right corner you select create app, and you configure the setup navigation permissions. So these are 3 different things that you have to configure, and then you're all set. All right, on to the next topic. Next up is configuring subscriptions. So subscriptions allow you to receive emails based on a periodic schedule. This can be set to daily, to weekly, or whenever the underlying data is scheduled to refresh. You can add up to 24 emails to a report, and it depends on how many and for who you want to subscribe, that you have to take into account the premium or regular capacity. So for example, if you want to create a subscription for yourself, this is possible if you have a Power BI premium license, or if the report or dashboards resides in a premium workspace and you've been given access to that workspace. You can subscribe others if you're the owner of the report or dashboard and you have a premium license. Subscribing to Paginated Reports is a little different, and you can check out the relevant redocs for this one. I think most important here is that you know if you have to set it up in Power BI Service, and that you can set up different frequencies for your subscriptions to go out. Alright, so far in this model we've covered the workspace access, and the different roles. We've also talked about deployment pipelines. We've covered data flows. We've covered applications, so publishing a workspace to an application, and then finally subscriptions.
Hello, this is Tijs again. So congratulations on making it through the entire course. It was quite a lot of ground that we covered. So by now you should almost be ready for the exam. What's left is of course practice. You have to practice all the things that we discussed, and especially the more complicated DAX functions like calculate, summarize, group by, and so on. So before I let you go, here are some practical tips that can help you to fully prepare for the exam. Alright, so as mentioned before, practice is really key for preparing for the exam. It's best for knowledge retention that you learn through different sources, so either books, Spotify, YouTube, and so on. Get comfortable with the Microsoft Docs, as these contain more information than explained throughout this video. Also try to get familiar with practice questions, which you can find online or on YouTube or through courses. Time is critical, so try to keep an eye on the clock and skip questions which might take a long time and flag them for review later on. Below, I also listed some items that are not fully covered in this course in case you wanted to check them out in detail. Now, thanks for listening to this course, and yeah, best of luck with the exam. Also make sure to subscribe to Call for Data, and then we'll catch you in another video. Thank you.